Alright, today we're going to do 3-4 perpendicular lines. This is Mrs. Briscoe, Miss Aitken's geometry classes. So remember, get out something to take notes on. Also complete the check it out questions and have them done by next class. And write down any questions that you may have and bring them to class.
Today we have one learning target. It is I can prove and apply theorems about perpendicular lines.
We have two definitions we need to go over. First is perpendicular bisector. So the perpendicular bisector of a segment is a line perpendicular to the segment at the segment's midpoint. So what does that look like? So you can see we have a line segment here, and it's been divided into two congruent pieces because we have the congruence marks here by a line that's perpendicular to it. So this would be a perpendicular bisector. The next definition is distance from a point to a line, the length of the perpendicular segment from the point to the line. So one thing to know about this, the length of the perpendicular segment from a point to a line is the shortest distance from the point to the line. And I will show you an example. So I have a point here, and here's my line. I can make lines from the point to the line, all different kinds of distances, but the shortest one is going to be this one that's perpendicular. You can see that this segment here is the shortest distance from this point to that line.
Okay, so in this example, it asks to name the shortest segment from point A to line BC. So as Ms. Briscoe said, the shortest segment is going to be the line from the point that's perpendicular to the side. So that's going to be segment AP. Our next question is to write and solve an inequality for x. We know that AP is the shortest segment, which means that segment AC over here has to be longer or greater than AP. So our inequality, I'll write the inequality out. So we know that again, AC, this segment over here, segment AC has to be greater than AP. Substituting the values, AC is x minus 8, and AP is 12. Solving for x, we get x equals 20, and that is our
X is greater than 20.
x is greater than 20. Thank you, Ms. Briscoe, since it's an inequality.
All right, this is your check it out example. So you will name the shortest segment from point A to BC on this picture, and then you're going to write and solve an inequality for x, and you're going to use the definition that we talked about in the beginning, that the shortest distance from a point to a line is the perpendicular distance.
Okay. We're going to cover three theorems today. The first is if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So the hypothesis, we have to have two intersecting lines. Here we have lines L and M intersecting. They form a linear pair of congruent angles by the congruent marks there. Now our conclusion is lines L and M are perpendicular. The next theorem we're looking at is perpendicular transversal theorem. It states in a plane if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other. So what we're going to be given are two lines that are parallel, and then a transversal that's perpendicular to one of the parallel lines up here. You can see by the box there. Conclusion is that it must be perpendicular to the other. So we have line Q is perpendicular to line P also. Now our last theorem we're going to talk about is if two coplanar lines are perpendicular to the same line, the two lines are parallel to each other. So our hypothesis is going to have two coplanar lines perpendicular to the same line. We have lines R and S. Transversal T is perpendicular to both lines R and S. So our conclusion is those two lines are going to be parallel. So So a line R is parallel to S. Yes, Ms. Briscoe.
So in the first one, if those angles are congruent, what does that mean their measures would have to be?
Well, they form a straight angle or linear pair, so they
Right.
have to be 90 degrees each.
Oh, so that's why they're perpendicular.
Yes, because perpendicular angles by definition are 90 degrees.
Okay, thank you.
Oh, you're welcome.
All right, so we're going to go through a quick proof. It uses one of our theorems we just had. So first, we're given R is parallel to S and angle 1 is congruent to angle 2. And we want to prove that R is perpendicular to T. So here's our picture. Notice it doesn't have the markings for parallel or congruent, parallel lines or congruent angles, so I'm going to add those in. So R is parallel to S, so there's the parallel line markings, just so I remember as I'm going through the proof. And angle 1 is congruent to angle 2. All right, so we want to prove that R is perpendicular to T, so here's R. Whoops, get my mark highlighted. There's R. Here's T. So what we want to prove is these are perpendicular. All right, so let's go through our proof. We know that we always start with what's given. R is parallel to S, and angle 1 is congruent to angle 2. That's we're given. Next one says angle 2 and angle 3 are congruent. How do we know that? Well, angle 1 and angle 3, or angle 2 and angle 3, sorry, are corresponding angles. We remember that from a few sections ago. So the reason we know that these have to be congruent is because corresponding angles are congruent when lines are parallel, and we're told R and S are parallel. Next we're told, or the next statement is angle 1 is congruent to angle 3. How do we know that? Well, transitive property of congruence, and remember it's congruence, not equality. Because we're told 1 is congruent to 2, 2 is congruent to 3, so 1 has to be congruent to 3 by transitive property of congruence. And then since 1 and 3 are congruent, so if we look at that picture, we have 1 and 3 being congruent. And our theorem says two intersecting lines that form a linear pair of congruent angles tells us that the lines are perpendicular. Sorry about that mistake on the... So this should be perpendicular. So the theorem says that they have to be perpendicular, not parallel. And that completes our proof.
Okay, now it's your turn to write 2-column proof. Do the check it out for example 2. You're proving the lines will be perpendicular.
So that concludes our lesson. What's our summary? First, a perpendicular bisector of a segment is perpendicular and cuts the segment into two equal segments. Secondly, a perpendicular distance is the distance from a point not on the line to the line. And remember, it's always the shortest distance from the point to the line. And then lastly, we had 3 theorems about lines and transversals that proves lines are perpendicular or parallel. So write your questions down. We'll see you in class.